So in this lab, you're going to simulate the initial stages of a ransomware investigation within the eCore network environment. You're going to draw on intelligence report detailing an emerging ransomware campaign. You will also analyze the provided data to identify early signs of compromise and understand the potential impact of this threat. The exercise focuses on examining how malicious Office macros, PowerShell-based payload delivery, and system recovery inhibition can align to form a complete attack chain. By reviewing host and process telemetry, you will learn how to detect suspicious behavior such as defender tampering, shadow copy deletion, and masquerading executables, all of which are commonly associated with modern ransomware operations. Before active hunting begins, the lab will help you contextualize threat intelligence, map TTPs to the MITRE attack framework, and prepare an analytic approach to identifying indicators of compromise within a real-world enterprise setting. Okay, as we talked about, the scenario starts really with this cyber threat intelligence advisory. So what this threat advisory is talking about is a ransomware campaign that is being conducted within the financial sector. So not our organization specifically, which in this case is eCore. However, in other financial institutions, this campaign is active. So the intent is sort of to provide a warning, an advisory, and also as threat hunters, we can take this report to start to build our threat hunt plan. So it talks about, in the subject, it's telling us it's a ransomware campaign that's leveraging Microsoft macros, so Microsoft Office documents. And it tells us who the audience is. So of course, it's our SOC, the leadership of IT, and the incident response teams, and should include also the hunt team. But we're wrapped up or rolled up under the SOC for this scenario. So the executive summary, and we've talked about reporting before. Basically, the executive summary is a big strategic summary of this report, because really your leadership is not going to read the technical details, but they are going to read the executive summary. So basically, I won't read it. You can read it for yourself. It's in the walkthrough. But it's basically what I just covered. It's talking about a ransomware campaign that uses multi-stage intrusion chain and identifies some of the MITRE attack techniques that are being used. So, for instance, some of the observed in similar organizations, so this is what they've observed in this campaign, is initial access using phishing email, and what they've actually identified is a .docm, which is a Word document. However, we should not limit our search to only, or our hunt to only Word. We should look at all Microsoft Office documents. And, once that document is open, it spawns PowerShell, which runs an obfuscated base64 command to download and execute payloads. And then it also talks about payload delivery and masquerading, which the payload they've seen so far is under a system file name like svchost.exe, which is a very common abused executable because it's so abundant in a Windows environment. However, it should not be running in the app data roaming. We'll talk more about that later. And they also set up persistence through scheduled tasks. And there are some defensive evasion techniques being used, such as disabling Microsoft Defender, deleting the volume shadow copies or the backup copies, and then stopping critical services like Windows Defender, the VSS volume shadow service, which makes those backup copies, and SQL Writer, which backs up the SQL databases. And then, of course, the impact is very serious from a business perspective. And there's even some C2 or exfiltration that has been identified. So, of course, not only or do ransomware operators now encrypt data, they also steal data and then extort organizations to either pay them additional money or they will release or leak that additional information. So we talked about MITRE attack mapping. So the Intel team has done that for us based on what they're picking up from other financial organizations or from the ISAC, the information sharing and analysis component. And we see what they're using for initial access is spear phishing, for executions PowerShell, and so forth. I won't go through, but if you need additional information on these techniques, then look up the ID on the MITRE attack page, and we've covered MITRE attack before in the past. And this is a business impact. Once again, I won't go into a lot of detail there, but the next section is really what we're going to be focused on, and that is the detection opportunities. So we can look for stuff like Microsoft Office. We can look for those PowerShell Cradle artifacts and indicators, things like ENC, which is encoded and no operation and hidden window. And we can also look for, we talked about SVC host a second ago. We can look for that, being executed from non-standard paths or directories, as well as suspicious scheduled task creation and so forth. So what you would do when you're developing your hunt plan is you would create SPL or the Splunk query language. And in this case, that is what we are using is Splunk as our SIM. So you would go ahead and create your searches for each of these key indicators. So everything that was in this report, you can pretty much develop an SPL to look for that type of activity. And then it talks about immediate action if you do pick up any of these indicators. So that's the scenario in the threat intel report. So what you would do now is develop your hypothesis, and the hypothesis is basically our organization eCore has been attacked, and through those techniques that are included in the threat intel report. So from there, just start your search based on the SPL that you create to basically look for each of these detection opportunities. So if you want to pause the video and come up with your own SPL, then go ahead and pause it now. If not, keep the video running and I'll go over the SPL that I created to find this activity. Okay, the lab setup is pretty simple and straightforward. I am using a browser on my host and I am logged into Splunk that is sitting on the Splunk server on that Ubuntu VM. So the first thing we want to do for lab setup is to download the logs, and that is in the walkthrough. So just select download. Once you've downloaded those, then we'll go to settings and we want to add data. So we select add data. We can skip those tours and we want to upload. Once you've selected upload, then move to select file and go to where you downloaded those logs, and then select it and select open. So once you've done that, you can go ahead and make sure that the selected file name is there, and then go ahead and select next. Here you want to make sure that the source type is CSV because it is a CSV file that we are uploading. And then we can select next. On input settings, a couple changes we want to make. We can go ahead and we can keep the host field value as it is. That's not important. We won't be using that. But however, under index, we are going to create a new index. And this new index we will call logs, just L-O-G-Z. And then we're just going to keep the defaults for everything else, and we'll select save. Once you've done that, we can go ahead and select review. And here we have uploaded file type is the input type, and the name of the file, as well as source type is CSV. We don't care about the host name of it, but we do care about the index equals logs, and we see that is correct, so we can hit submit. Once you've selected submit, then those logs should be ingested into our Splunk instance, and we can select start searching, and you should get a bunch of results. So that's, once you've gotten this far, then the setup is complete, and then we can just jump into the lab. But one thing I will point out is we don't need all this stuff in our search window. All we really want to do is have index equals logs, and then we want to make sure all time is selected on our time range, because this data was recorded in August of 2025. So if you went with last 24 hours, then you're not going to pick up any fields. And we can just run that again, and you see that we basically ingested over 1,000 events. So if you're getting something near 1,040, then you have successfully ingested the logs. The first SPL that we want to run based on our threat intel report is we want to look for Microsoft Office spawning PowerShell, and as well as any obfuscation techniques that PowerShell is using. So we're going for event ID 1 on sysmon, which is process creation, and we want that parent process or that parent image to be a Microsoft Office document. So either Word or Excel or PowerPoint. And then what we want to see is that is the parent process. We want the process to be PowerShell, which is why we have image equals PowerShell. And then we want to look for those obfuscation techniques, things like ENC, which is short for encoded, or NOP, which is the no profile, and of course the -W hidden, which prevents a PowerShell window from opening up when PowerShell runs. And then we are going to pipe that to a table that is going to include the time, the computer, the user, the parent image, the image command line, and the parent command line. So when we run that, make sure that you have your time selector either set to all time or to August 25th, and then run that SPL, and you see we get a hit right away, and we look at the time, and the user we see is Arlen, and we see the parent image is Word. So that's what we were expecting, is a Microsoft Office document, and we see that it spawned PowerShell, and we see the command line exactly what we were looking for when we did our SPL, because of our threat intel report told us that they were using that PowerShell cradle to go ahead and download the payload. So what we can do at this point, we could copy this base 64, and we could open CyberChef to see what that base 64 is. And really, CyberChef is the safest way to do it. Earlier in the course, we talked about a PowerShell command that would decode base 64, but that's not a good idea because you don't know what that PowerShell command is actually doing, or what that base 64 is actually doing. You don't want to start a malicious process. So I've pasted the base 64 into the input window, and then all I need to do is drag from base 64, and we get some results down here. Now, as we've seen before, we see a lot of null bytes, and those null bytes make it sort of hard to read with the naked eye. So let's go ahead and remove those null bytes just by moving the remove null bytes operation into our recipe. And now we clearly see in plain English, we see a URL, which is HTTP, then the IP address, and we see an executable known as p.exe, and we see some other functions. So we've been able to figure this out from that first SPL. Now, as a bonus, can anybody tell me why this would not work? As you can see, there's only 3 octets. There's not a 4th octet in that IP address. So that is to prevent actually reaching out to a IP address. But in reality, of course, there would be 4 octets. And what you could do with that IP address at this point is copy it, paste it into VirusTotal to see if there's anything reported on that IP address. You can also look at any of your other threat intel resources that you have available where you can look up IP addresses. But that's from the very first SPL. We've already discovered that yes, there is a system in our environment that does have indicators of compromise of this campaign that we read about in the threat intel report. The next SPL that we want to run, or next thing we want to look for, is based on those non-standard executables in the user directory. So what do I mean by that? And I'll paste the SPL. Is once again, we're looking for process creation, which is event ID 1. But what we're looking at is the SVC host, which is very commonly abused by threat actors because you see many SVC host instances running at any given time. However, SVC host always executes from within Windows System 32 and then SVC host. So what our search is doing is basically looking for SVC host, but it's looking for it not in this path. So basically, it's not going to return any hits if it is in this path, because that is the legitimate path for svchost.exe. And then we're creating a table once again with that relevant information that will make it easier to analyze. So if we run that command, we see we get a hit, and we see where that SVC host is being executed from is in the user's app data roaming directory. So anytime you see SVC host running from anywhere except for that Windows System 32, then there's something amiss. So it's most likely malicious. It is certainly suspicious. Then you want to look it up. And then if you look at the command line, you see the -silent. That's a bit suspicious. And we see that it was launched by PowerShell. So now we're definitely suspicious. And then we just get the MD5 hash of that particular SVC host. So we could check that hash there, and we could just throw it into VirusTotal if this was real malware to see if there's been any hits on that. And if it comes up with anything other than SVC host, then we know that this is suspicious, likely malicious. Yeah, if you see PowerShell executing things like this, then obviously you've got a problem, or at least a potential problem that you want to go ahead and do more research on. So the next thing we want to hunt for is scheduled task creation, or suspicious scheduled task creation. And that was in the threat intel report as a step that they are using in this particular campaign. So I'll go ahead and paste that SPL. So we're looking for event ID 4698. So obviously this is not a Sysmon event. This is a Windows event. And we're looking for, and what 4698 is task creation. And we're looking for scheduled tasks, or the command line where we see users, and then we have a wildcard there because the user is going to be different every time, but the app data roaming. So anytime, so we're basically looking for a scheduled task being run from that app data roaming directory, which remember, that is where we saw that svchost.exe being executed from inside the app data roaming directory. And then we have it going to piping it to a table. So when we run this, we do get a hit, and we see what that task actually is we see some of these commands, and we see that it is running from that app data roaming directory being executed from that SVC host. So that SVC host.exe, what it's doing, as we can see, is it is creating a scheduled task. So of course we know that scheduled tasks are used by the adversary to either create persistence so that if they get bumped off, a task will run and give them access again, or maybe to launch either malware or something at a later time. But it's always good to look in the scheduled task when you're looking for signs of persistence. Now we've also, the threat intel report talked about they would try to tamper with Defender. So, Microsoft Defender, very common antivirus engine on many organizations use. So to discover that, what we want to do is run this particular SPL. Once again, we're looking for process creation, and that process is being spawned by PowerShell. And what we're looking at is disable real-time monitoring. That's what we're looking for, is basically a PowerShell command that would disable Microsoft Defender, which is real-time monitoring. And you probably ran into that in the labs sometimes when you want an attack to take place in a lab environment to see what kind of telemetry that attack would produce. You have to disable real-time monitoring, or Windows Defender will go ahead and stop that attack from taking place. So in a lab environment, you want it disabled. Obviously, in a production environment, you would not want it disabled. And when we run that, we see we do get a hit. And sure enough, when we look at the command line, it is PowerShell, and it is running that exact command that was in that threat intel report. So now what we can do is go ahead and pivot now back to our threat intel report to see what else this campaign is doing. And one of the things that it is doing is deleting the shadow copy. So remember, the Microsoft shadow copy is a backup of everything on that system. And the reason somebody would want to delete it is definitely suspicious. Is obviously if somebody executes ransomware on your system, they want to make sure all the backups are deleted, or else you could just revert back to the latest backup or shadow copy. So the tool to do that is called vssadmin.exe, and the SPL that you would look for that will be on the screen. Once again, it is event ID 1, which is process creation. And what we're looking for is the image vssadmin. I've got a wildcard there before that. But vssadmin.exe is the executable that makes these shadow copies, and also is the executable that's used if you want to delete the shadow copy. But it would be in a command line, and if the command line must include the words delete shadows, and you see I have wildcards both on the front and trail end of delete shadows, and then piping that to our table. So when we run this, we see again, we have a hit for exactly what we're looking for. vssadmin.exe, delete shadows, all quiet. So what all of course means it's deleting every shadow copy or every backup that you have. And then quiet is it's doing it behind the scenes. So there's not going to be a pop-up. It's similar to the -W hidden on PowerShell, where you don't want the adversary does not want PowerShell window popping up and showing what they just executed. And the parent image, all this again is being run by that masquerading of svchost.exe. So that is the malicious file, and that is what is spawning this activity. So we've just discovered that they are deleting the backup files. So the next thing we want to look for is critical services being stopped, including what's called VSS. That is the volume shadow service. That is the thing that's making these shadow copies. So what the adversary does not want to do is delete all the backup copies, and then this service creates another one before they get a chance to deploy the ransomware. So what they'll do is just turn off that service. So they'll turn off the service and they will delete all the backup copies. And some of the other services that they may turn off, we talked about tampering with Defender, but they can just turn that Defender service off in general, not just the real-time monitoring, and any kind of SQL backups or anything like that. So the SPL that we'd want to create to look for these critical services being stopped would look something like this, where we're looking for event ID 1. And if you're not familiar with sc.exe, that is basically the service creation. So anytime a service is either being enabled or disabled or modified, they're going to be running sc.exe. And then in the command line would be the word stop. Now you notice I have wildcards on both the forward and the trailing end. So it's going to be, the command line itself will be a lot more than just the word stop, but the key word is stop. And anytime you have this image, sc.exe, and then a command line saying stop, then that is going to stop a service. We also have a Windows event ID 7036 that also picks up services entering a stop state. So what I'm going to do here is just, typically your like sysmon is one index and one event might be another index, and then you just run multiple ones. But the way we ingested this data is the entire index is just called logs.exe. So I'm modifying that a little bit. It should be updated in your walkthrough. But basically, we're looking for event ID 1, which is process creation, along with this information, or event 7036. And then from there, we're searching from the command line. We're already looking for stop in the command line, and then we're piping that to a further search, looking for WinDefend with wildcards. Of course, that's Windows Defender. SQL Writer, because that is used to create backups of SQL databases. And then VSS is a volume shadow service, which creates those backups we talked about before. And then we have some other words, some other keywords that you see here. Looks like we have some duplicates. So once again, I'll update that in the walkthrough. And then I'm pushing this to a table similar to what we've used before. And I see an error there because of that. All right, so we run this SPL, we get some hits, and we see these services that are being stopped right here in the command line. It's all three that we were looking for: VSS, SQL Writer, and Windows Defender. So we're able to confirm this activity as well as what system it's being used on and what user the adversary is operating as. So the next thing that we want to look for is file encryption. And when that file encryption, like in ransomware, when that kicks off, we're talking about a lot of a very large volume of file writes, and then they end with a different extension. In this particular campaign, based on our threat intel report, that extension is .locked, L-O-C-K-E-D. Now, it depends on the type of ransomware, but typically each ransomware family has a distinct file extension, and that just you know that that file has been encrypted. So we can craft a SPL that would pick up that encryption, and it's going to be based on that file extension. So once again, I'll paste it into our search. So we're looking for event ID 11, which is file creation, and the target file name is wildcard, then .locked. So once again, we're really focusing in on that file extension. And this ransomware, once again, is running that file extension called .locked. So that's what we're looking for in this case. And then what we're looking for, we're using a technique called bin. So what we're doing is looking at 1 minute intervals. So a bin is like considered like a box, everything within 1 minute. Now, one thing I will point out in the way bin works when you're running it is 1 minute, 60 seconds, but it's on every minute of time. So at 1 o'clock and 1 minute, it starts and it ends at 1 o'clock and 2 minutes. And then it creates another bin with from 2 o'clock or 2 minutes to 3 minutes and so forth. But it's looking within that 1 minute bin, it's looking for these file creations more than 50, greater than 50. So where the count is greater than 50, because we're using stats to count this. And what that means is over 50 file creations, or basically the file extension going to .locked within 1 minute time span. Because as I said before, when ransomware operates, it encrypts everything as fast as it can. So if you're going to set some kind of a detection, in this case we're hunting, but if you're setting up a detection rule, you want to create a large number or more than just one file within 1 minute. So we're going 50 here, and in reality you may want to set that higher, but we want to make sure we catch it in this lab environment. It was a little bit didn't have as many files to encrypt as you would if this was in a production environment and this was a true ransomware attack. So when I run this, we see that we do get 3 different occasions. Remember, I was talking about those bins being for 1 minute. So at 9:34, 9:35, and 9:36, we see there were 60 files being encrypted in each of those 1 minute bins, and that met our threshold of 50. So we're able to now confirm that, and with this file extension, that definitely ransomware has been deployed on this particular machine. The next thing we'll look for is the ransomware note creation. So what we can do, and based on our threat intel, or basically what happens is a ransomware note is created and is put like on the desktop, or sometimes I'll even change the desktop, because of course the ransomware actors want the user to realize that they just got all their files encrypted, and that ransomware note will include instructions on how to pay to get the decryption key so that they can get their files back. So we are able to craft an SPL to look for that particular, to look for that ransomware note. So we're looking for, once again, event ID 11, which is file creation, because that ransomware note is a file. And the target file name, we're looking for one of several. We're looking for, sometimes that is called, readme, recover files.txt, or how to decrypt.txt, or decrypt instructions.html, different variations of it. And then once again, this usually is consistent within a ransomware family. So if it's a specific ransomware family, and especially in a particular campaign, then that ransomware note is always going to be the same. So what we can do is just look for the creation of that ransomware note. If we looked at the, let's look at the time again, 9:34 is when the encryption started. It looks like it ended at 9:36 something. So it'll be interesting to see when that ransomware note was created if we find it. So we'll do the search and we find the ransomware note is actually called README, recover files. And once again, you can see the image that's creating it is that SVC host. So that is the ransomware file. You know, we knew it was suspicious and then pretty certain it is malicious just based on its location. But now the activity, we can see that it's clearly the ransomware. And we see that that ransomware note was created at 9:37. So it was right after all the files were encrypted. So this encrypts the files first, and then it creates this ransomware note and probably places it on the desktop where, yes, and we see where it's placed. It's on the desktop so that the user will be sure to see it. So the next thing we can do is look for any C2 traffic. Now C2 traffic, well, the activity itself is easier to pick up, but if you're looking for it for a specific IP address, it's really next to impossible to pick it up by IP address. And the reason I'm saying that is most ransomware operators change their infrastructure multiple times in a day, and they'll use multiple IP addresses to use for command and control. So if you have a list of indicators and it's C2 IP addresses, do your due diligence. Still, you want to search, you want to try to detect those IP addresses. However, just be aware that it will be difficult to pick up because they change their IP addresses quite often. And what they do is they don't own those IP addresses. They'll compromise servers, all over the internet, and they'll use those compromised servers to act as C2. So the search that we're looking for right now is we're looking for network connections, and we have an IP address that was one that we got through threat intelligence, that this IP address was being used for command and control. And we're also, event ID 3 is a network connection, and event ID 22 is a DNS query. So we're also looking for DNS queries to these domains, which is cdnupdate-sec.com and -sec.com. You see different variations of that domain, which we got through threat intelligence. And if we run that, we can see that we did have some activity from that IP address, and we see using a destination port 443, which of course is HTTPS, but we also see a port 4444, which they'll usually use some non-standard port number for C2 traffic. And you'll see the image. So remember svchost.exe in that app data roaming directory is a ransomware. So that ransomware is calling back to this IP address on this non-standard post. Initially, this PowerShell command reached out to this IP address over 443. That was probably to download the ransomware or the secondary payload. But at this point, we've picked up the C2 traffic, and hopefully we picked that up through some other network sensors as well. And the last thing we want to look for is any signs of security log clearing. So basically what that means is they're going to wipe your security logs so that you wouldn't be able to do an investigation and discover their activity. So what we're looking at, a event ID 1102, which is an security event to clear the logs. Now, it is suspicious unless it's a known maintenance activity, which event 1102 is used as I said, to sort of clean up the logs. So it should be tightly monitored. If we do a search for that particular event ID, we see that it was run at 9:37. So basically, if we put a whole timeline together, what we would see is we saw that encryption activity, then we saw the ransomware note, and now it's cleaning its tracks by clearing the logs. Now, the good thing about a SIM is if it's recording those logs in real time, even if you wipe all the logs off the host, you still have it in your SIM, because it's when they clear these logs, they're not able to clear the logs that have already been forwarded and ingested into your SIM. So that's the SPL that we're able to craft from that threat intelligence. So it's not always going to be, this easy where the threat intel nails every single thing that they're doing. But this is just to demonstrate how you can use threat intel to create your hunts. And remember, hunt is proactive, not reactive. So this whole hunt process was initiated because of that threat intel report and because of the activity that we're seeing within our sector, not necessarily our organization. But if we were a financial institution, then other financial institutions have seen this type of activity or these types of attack. So we would hunt based on that. And as I said, that's proactive, where incident response is reactive, saying an alert went off for any one of these events that we've just discovered using our SPL. If we had set up detection rules that trigger alerts, then that would be reaction. So technically would not be threat hunting, although we would be using the same process. That's just to clarify sort of a question that's asked a lot is what is the difference between threat hunting and incident response. And the answer is one's proactive and one is reactive.